Alright, so I'm going to show one of the few advantages to designing a drive system around stepper motors. I've just recently gotten my program set up to give me a precise spin angle, so I can tell the robot now to make a particular turn in a particular number of degrees, and it can go about doing that. The reason that I can do that pretty easily is the fact that stepper motors are by nature, they're kind of like a digital output. So you tell it to move so many steps, and that turns the motor shaft just that far and no farther. Whereas normal DC motors are continuous rotation. So as soon as you put power on them, they just start rotating and they keep going. So in this case, I can tell the robot to move each wheel a particular distance, and it can do that and do it fairly precisely. So I'm going to go ahead and tell it to move 90 degrees. Okay, so it can make that 90-degree turn and stop exactly where it needs to. Now I can tell it to move in 180 degrees back the other way. Speed. And you see it lands pretty much right on the nose with a 180-degree turn. But I definitely do like the fact that if I want to navigate around, I can give it very precise commands. So for instance, I want to move now 45 degrees back. I can do that, and I can do it very precisely. So anyway, that's the latest development on it. The other little thing that's happened here is, in order to conserve battery juice, I have set the robot up with an automatic disable. So the stepper motors themselves take up quite a bit of juice even if they're not moving. The way stepper motors work is that whenever you've got power going to them, they take almost about the same amount of current as they do when they're turning. There's a little bit of difference, but not much. So the net result is that if they're sitting there and they're just on, then they're just burning juice. So what I set up here was a system where this guy automatically disables the motors if it hasn't received a new command in 10 seconds. So if I go ahead and I tell it to enable the motors here real quick, see that little light come on back here. In just a moment, since no other commands came in, it goes ahead and disables them again. And as soon as I tell it to do something, so we'll tell it to make another little turn here. So as soon as I tell it to do something, it will go ahead and enable itself again, wait for the next 10-second interval, and disable if nothing's come in. So that will save a ton of juice, because right now the battery that I have will last about, I'd say an hour, maybe an hour and 20 minutes of just the machine sitting there on with the motors burning the juice. If I disable the motors after each command, I can sit here and play with it practically all day, and it will not run out of battery. So even with the battery running the logic circuits. So I think I'm in pretty good shape as far as power goes. Right now I've got it hooked up to a giant lead acid battery, but that's not going to be the it's not going to carry that thing around. That's probably 12-13 pounds of battery right there. Makes my nice bench power supply though. So anyway, that's where things are at. The last development we've got here is I did get the Omni wheels from Robot Shop, and these are, the company that makes these is Vex. I picked up the I think these are 2 3/4 inch, I think that's right. So I picked up this size because the only other size they have is a 4-inch, which is just a little bit larger than my front wheels, and I didn't really like the posture of the larger wheels being in back. So these guys are a little bit smaller. As you see, there's a size difference there, so they can't be in line. They've got to be lowered down a little bit. I've been trying to come up with some bracketry that will hold these wheels that doesn't look like hammered butt, and I think I'm coming in on something that I can at least live with for the time being. The nice thing about Omni wheels is instead of a caster in the back, I'll now have 4 wheels. So these wheels can move forward, and they can slide side to side with very little resistance. You'll see here I can push it. And it will just roll around sideways. That's provided by each one of these little separate wheels set within the wheel. So that means that the robot can, roll forward, and then when we go and do those spin moves, then the tires can just spin side to side, and I don't need that rear caster. So that's where things stand. I'll have a few more videos here as I start to get some of the metallic, the deck cut out. I'm hoping to get the designs done for that this weekend, and maybe get started on it a little bit.